Nice to have you on this platform. We will continue with jam pass question 2001. Question number 3. The question goes this way. A stone of mass 1 kg. A stone of mass 1 kg is dropped from a height of 10 meters above the ground. Height of 10 meters above the ground. The stone is dropped. Its kinetic energy 5 meters above the ground is then equal to its kinetic energy 5 meters above the ground is then equal to. Okay, let's see what the question is all about. Okay, the question wants to test the student's understanding of free fall. As a student, are you aware of what happens between kinetic and potential energy when it comes to free fall? Anytime a body of mass falls under gravity, we say that potential energy is equal to kinetic energy. Are you aware? Okay, for a free fall, potential energy is equal to kinetic energy. Energy conversion takes place. Why? Okay, let's see why. Okay, observe from the board. Okay, let's say a body gets to a certain height. When the body is moving from the ground level to that height, the body's height is increasing. 0, 1, 2, 3, 4, 5, 6, up to 10 meters. As the question portrayed, 10 meters. So we say that potential energy here is maximum. Potential energy there is maximum, whereas potential energy here is minimum. Okay, what do we mean by maximum and minimum? Maximum indicates that the highest height will have the highest potential energy. Let's presume 1000 joules, for instance. Then the smallest height, which is 0, will have the smallest potential energy, which is what? 0. So here is 0 joules. So what point am I trying to make? Potential energy is due to height. When the height is maximum, the potential energy will be maximum. When the height is minimum or 0, the potential energy also becomes what? 0. 0 joules. Therefore, PE, potential energy, is due to height. Then energy conversion takes place when the body begins to fall. When the body at 10 meters high begins to fall down, when the body begins to fall down, something unique begins to happen. Notice, the height begins to lower. And as the height is lowering, the potential energy is also doing what? Reducing. As the height reduces, the potential energy will also do what? Reduce. But the kinetic energy will start doing what? Increasing. Because any falling body, its speed is increasing. That's what we call acceleration. Increasing speed. So because the body here, at this point, begins to fall down, its height begins to lower, thereby reducing potential energy, but the speed begins to increase, thereby increasing kinetic energy. Then see what will happen. Then the kinetic energy at these same points, the kinetic energy at the maximum height is minimum, or 0 joules. Why is it minimum? At maximum height, the body is held at a fixed speed. So the speed at that point is 0. When something wants to fall, first of all, you hold it. The speed at that point of holding is 0 meters per second. So that's why kinetic energy is due to speed. Therefore, it becomes 0 at the maximum height because the speed at that maximum height is 0. But just before it strikes the ground, the kinetic energy becomes maximum. That giving us 1000 joules. 1000 joules. Just before it strikes, I didn't say on the point of striking the ground. Just before it hits the ground, you get the highest speed. And that will give you the maximum kinetic energy. Then notice something. That same energy that was stored as potential energy at the maximum height is the same energy stored as kinetic energy at the minimum height. This is what happens in free fall. Therefore, we say PE is equal to KE for a free fall or for a falling body. For a falling body, kinetic energy is the same as potential energy because the energy stored as PE is the same energy that will be released as KE towards the ground level. Therefore, for free fall, PE and KE will share the same formula. Then let's solve the question. Okay, because the body is falling, we say free fall. Solution, free fall. KE equals PE. So they are equal. So we can use either of the formula. We can either use half mv square or we use mg hash. This is one for finding kinetic energy. That's one for finding potential energy. You can use either of them because they are equal. But your parameter decides the one you will use. Observe the parameters. Okay, let's see what we have in our parameter. We have mass, 1 kg. We have height, 10 meters. Then we're now asked to get the kinetic energy at another height. We have second, this height 1, this height 2, 5 meters. Then G is a constant. G is 10 meters per second square for the Earth's surface, acceleration due to gravity, 10 meters per second square. Okay, so the question is targeting the kinetic energy at that point. So you can see from the parameters we'll be using this formula, mgh. mgh. So we'll go for that, mgh. That's our kinetic energy for now. Because kinetic energy is the same as potential energy for a free fall. Then let's solve. Recall the height of consideration or concern now is 5 meters. So I will have mass 1 times the height favored is 5 times g, which is what? 10, a constant. To be having 5 times 1, 5, 5 times 10, 50. 50 joules. 50 joules. Another way you can solve this is using the 10 meters height. Recall, 5 meters is half of 10. So after getting the energy stored at the maximum height, half of 10 is 5. Therefore, half of that energy will also be the energy for 5 meters. So that is, you can also use mgh again, 1 times 10 times the height, 10 meters. Everything divided by 2. We're getting the same answer again. 10 times 10, 100 over 2, 50 joules. This is always the kinetic energy at 5 meters height. Kinetic energy at 5 meters height. Okay, then let's go back to our options. So the first option says that the kinetic energy at 5 meters above the ground, X, A, its kinetic energy on the ground, okay, is equal to A, its kinetic energy on the ground. Recall, kinetic energy on the ground will be, recall that the total energy stored at the maximum height is 1 times 10 times 10 without half. The total energy at that maximum height, which is 10, that is 100. That times 2 of this, 100 joules. Then kinetic energy on the ground. Okay, this is on the ground, not before the ground. Kinetic energy on the ground is also 0 because it has touched the ground. But before the ground, the very point before the ground will be 100 joules. So this is incorrect. A is incorrect. Then kinetic energy 5 meters above the ground is equal to, go to option B, twice its initial potential energy. Okay, the initial potential energy is the 100 joules. That's energy at 100 meters. So twice of it is 200 joules. Wrong. C, its initial potential energy. The potential energy at 10 meters is 100 joules. So that's wrong. Then D, half its initial potential energy. So the potential energy at 100, forgive me, the potential energy at 10 meters is 100 joules. Therefore, half of it is 50 joules. Option D is the best option. From our solution, you can see that the potential energy or the kinetic energy at 5 meters height above the ground is 50 joules, which is half its initial potential energy. And that potential energy, mgh, considering the mass of 1 times g10 times the maximum height, 10, we'll be having 100 joules. Half of it is 50 joules. Thank you.